Hey guys, it's Mr. Ewart here. And we're going to go over rules of exponents today. And if you don't have some paper and a pencil or a pen, go get some now. You really do want to take notes on this, write these rules down, because when you're doing them on Delta Math, it's going to be really helpful to have all these rules right there in front of you. So you can title your notes Rules of Exponents. And if you need to pause the video, go get some paper, do that now, and then we'll get going. So just kind of what we're trying to learn today. We're trying to learn, rewriting expressions involving rational exponents. Rational just means that we can divide two numbers. Um, it's pretty much all numbers that we can think of that we'd be able to say using the properties of exponents. And so there are going to be 6 properties of exponents. And just some quick vocab review. Anytime we have a monomial, that's a number, a variable, or a product. So 3 would be a monomial, x is a monomial, 2x is a monomial. But if I had like x plus 3, that's not a monomial because of the plus, because we're adding 2 different numbers. And then a power is, when we're thinking of a power, we're thinking of the base and the exponent. A lot of students will see 5 squared and they'll accidentally say it's 10. It's not 10, it's 5 times 5, so it's 25, right? So the base is the number that's being multiplied, and the exponent is how many times. If we had 5 cubed, that would turn into 5 times 5 times 5, which the first 2 5s are 25. So that's 25 times 5, which you could do out, use a calculator, but you'll get 125. So when we're talking about the base is this 5, right? That's our base. It's the number that's being multiplied, and the exponent's the small number up above, which is how many times are we doing that. So when we talk about rules of exponents, these are our properties. We're going to have 6 of these. So just in your notes, put a number 1. And just copy everything down in this kind of grade box, all of this, especially this part. But when we multiply, you can copy all of it. When we multiply 2 numbers with the same base, so that's our key there, is that we have the same base, then you add our exponents. And a lot of this is going to be review from you guys. So when we think of like x squared times x cubed, we add the 2 plus the 3, and we get x to the 5th. So that's what that rule is saying. This is from a textbook. Visa's a college preparatory high school. When you guys get to college, a lot of the books will use A. And for exponents, they might use M and N. If you're not used to that, it's okay. But the key is that the A, that's our base. Whatever it is, A is just standing in for anything. It could be X, it could be 3, it could be 5, it could be 10. And M and N, again, are just standing in for numbers. So 5 squared times 5 to the 6th. You don't have to write this part down, right? But it's 2 plus 6. 5 to the 2 plus 6, which is 5 to the 8th. So I know most of us can do 2 plus 6 in our head without writing it down. You don't need to give the number, right, in Delta Math. You can just write it 5 to the 8th like that. And to write this on a computer, you're going to use the caret symbol, which is shift and then the number 6. So you hold down shift and you press 6, and it's going to give this caret, and that'll allow you to create the exponent. So that's how you type it. All right, y to the 4th times y cubed times y. On this one, we can just do the first 2 first. But this y, we want to be careful about it. It does have an exponent, has an exponent of 1. So anytime we don't have an exponent written, it's always to the first power. And in math, it's the same reason why we don't write 1x. We just write x, because mathematicians are a little bit lazier, and anytime there's a 1, they don't want to write that because it's 1 times anything is itself. Same thing with exponents. But when we're using these rules, it's helpful to write that 1 in so that we know that we have to add that on. So y to the 4th times y cubed gives us y to the 7th, but still times, we need to bring this down, y to the 1st, and y to the 7th times y to the 1st is y to the 8th power. If you wanted to do it all in one step, you could. 4 plus 3 is 7, plus 1 is 8, and you could just jump straight there. All right, now what if we have a number? So in this one, we have a number and a variable. Well, I like to kind of just underline. So I underline my numbers once, and then my variables twice. And we're kind of almost like terms, but we're multiplying. Remember, when you have two parentheses like that, you're multiplying those. So 7 times 6 gives us 42. And y to the 5th times y, remember there's a little 1 there. 5 plus 1 gives us 6. So 42y to the 6th. All right. Next, again, I'm going to do that same thing. Underline the numbers once. X is twice, and this time we have y, so I'm going to underline those 3 times. Right, just looking for our like terms. Negative 3 times 5 is negative 15. X squared times x, I'm going to put a little 1 in there. X to the 1st gives us x cubed. And 7 plus 6 gives us y to the 13. All right, there we have it. So if you need to pause that video, go back, make sure you have all those examples. We're in, okay, number 2. And again, get this written first. I'm going to keep moving on so the video doesn't drag, but just pause when you need to. So when quotient is dividing, whenever we're dividing with exponents, we always subtract. And, so whenever you have the same base and you're dividing, you subtract the exponents. So first off, we have y to the 6th divided by y to the 1st power. And that gives us 6 minus 1 is y to the 5th. Right, so just 6 minus 1. Some people will kind of cross out the 1 there, and then they'll just put minus 1. That's helpful. So 6 squared and 6 to the 13th, cross out the squared because it's smaller, and then 13 minus 2 gives us 6 to the 11th. By the way, technically it is still divided by 1, right? When this cancels, it's divided by 1. But we don't really write that divided by 1. We just, in math, you don't need to write that. So it's just 6 to the 11th power. All right, and then in this case, I'm going to actually change this problem a little bit. Or I'll do it a second time, actually, because I want to show one more thing. But this one's a little bit different because of the numbers. But just, pretend, hey, let's ignore the variables for a second. What if we just had 10 divided by 15? How do we simplify that? Well, they're both divisible by 5. So that gives us 2 divided by 3. So it's that same concept here with our like terms. So I'm going to underline my 10 and my 15 once, my a's twice, and my b's 3 times. And 10 divided by 15, if we divide by 5, right, we get 2 on the numerator and 3 in the denominator. 7 divided by 5 is a squared. Right, we're going to get rid of the 5, and then 7 minus 5 gives 2. All right, and then on the b to the 9th, 9 minus 9 is 0. So we get b to the 0. And I'm going to leave it with b to the 0 right now, and we're going to come back to this problem because one of the next rules tells us about what happens when we have a 0 power. So we're gonna come back to this, and we're going to even simplify it more. Okay. Now, I do want to show one more example I had in here, but it got deleted. What if we had the same problem almost, but instead we had 10a to the 7th, b to the 9th, over 15, a to the 5th, but what if we changed in the denominator? We're going to change this to say b to the 12th. So I'm going to change that just a little bit. So it's going to start off the same, where, we divide by 5, and so that gives us 2 over 3. And then same thing here, I'm going to get rid of the a to the 5th, and 7 minus 5 gives us a squared. But here we want to be careful about it, is I always like to subtract the bigger number. So b to the 12th is bigger, so I'm going to subtract there. So what I'm going to do is I'm going to cancel out the b to the 9th, and I'm going to do minus 9 in the denominator. So now 12 minus 9 gives us b to the 3rd power, but notice it's in the denominator because that's where it was bigger. So you just want to be careful about that. Same thing, I'll see students who have a problem like this, x squared divided by x to the 5th, and they'll get the wrong answer. They'll say it's x cubed because they did 5 minus 2, and they get x cubed. But remember, where is that x cubed? It's in the denominator. So there still is a numerator. And what happens is that's why I like to kind of write it and show it being canceled out. So minus 2, when we cancel anything out in math, it always becomes 1. So it's not x cubed, it's 1 divided by x cubed. That x cubed was in the denominator. Okay. All right, next rule is the 0 rule. So any exponent to the 0 power is always equal to 1. So this is our third rule. Again, make sure you're writing these down. So anything to the 0th power is 1. And kind of to explore this, right? If I had 8 squared divided by 8 squared, if we did the rule number 2, right, cancel that out, and minus 2, we get 8 to the 0th power. But we don't know what that is. I mean, I just told you it was 1. But to kind of prove this is, well, what if instead we said, okay, well, what is 8 squared actually? 8 squared is actually 8 times 8 is 64 divided by 64. And we know in math that anything divided by itself is 1. So we can kind of see that these are the same thing. So, and this works for all numbers, all variables. Anything to the 0th power is 1. So in this case, we have a parentheses. So this 0 is saying everything inside the parentheses to the 0th power. So this whole thing is 1. Okay. And so going back, I said we were going to come back to this problem, right? Well, we know that this b to the 0th power is 1. Now, the whole entire thing in this case isn't 1. Not the whole answer. Only the 0 is only going to the b, right? So only this b to the 0th power, this part just right there, that's 1. So what we can do is we can kind of rewrite this as 2a squared times 1, right? And we know anything times 1 is just itself, so we can just rewrite this one as 2a squared over 3 and kind of get rid of that b to the 0th power. All right. Now, this next one is really tricky, and a lot of people get this one wrong, and they just put 5, and they write the answer is 5. The answer is not 5, okay? I want you to try to look at it, think about it, give me a guess for what your answer is just in your head, but the answer is not 5. And the reason it's not 5 is the 0th power is only going to the x, right? When we say 8x squared, it's not 64x squared. That would have been wrong, right? It's just 8x squared. That's all it is, right? Because the squared is only squaring x. Actually, the 8 does have an exponent. It's 8 to the 1st power, right? Because there's only one 8. Technically, you could get into it really into detail, and you could say you could write it as like 2 cubed. 2 times 2 times 2 is 8. But we're just writing it as 8. So anytime we have a number, right, if I have 8x squared, it's just 8 itself. So this 0 power is only going to the x. So what happens is that part's 1, but the 8's going to stay there. So this is like having 8 times, right, because we're multiplying 8 times x to 0. So 8 times 1 plus 5, and then we do PEMDAS. So multiplying first, 8 times 1 is 8. And so we get 13. All right. Rule number 4, right, is our negative exponent rule. Okay, our negative exponent rule says anytime we have a negative exponent, that negative exponent goes to the denominator and turns positive. Now, this rule also works backwards. So if it started off in the denominator, then it'll flip up to the numerator and turn positive. So essentially what's happening with our negative exponents is they flip sides. They flip between the numerator and the denominator, and then they can change signs. They can change back. So if we kind of think about that, right, I showed you, hey, what I like to do is I like to cancel out the squared and write it like that. So this would have been 1 over b cubed. But could we have also done it b squared over b to the 5th? Couldn't we have done b to the 2 minus 5 power? which would have been b to the negative third power. So we did this 2 different ways, and those are going to be the same answer, but they're just written differently, right? And the reason is, hey, if we take this to the negative third, we can move it to the denominator and turn it positive. So when we're rewriting these, right, if I have 2 to the negative third, we just write 1 divided by 2 cubed, right? And on delta math, just 1/2 shift 6 gives us that caret to the power of 3. Okay. -3 to the negative 3. That whole entire negative 3 is in parentheses, so we're going to move it all in parentheses to the denominator and turn it positive. Right? If we had a little bit of a harder example, say we had x squared, y to the negative 3 over x, let's just leave it like that. So this y to the negative 3, only that part has a negative exponent. So that part's going to flip down, and we're going to get x squared over xy cubed. And now we're just looking for our like terms. Well, this is x to the first power. So one of them is going to cancel out. Get x over y cubed. So that's a little bit of a harder example. All right. Moving on. These 2 rules are going to kind of be together. So I'm going to call this 5 part A and 5 part B. It's pretty much the same rule, but just one of them has one thing inside and the other one has 2. So a power of a power. Anytime we have a power raised to another power, then we multiply the exponents. So if we have x squared to the 8th power, we multiply the powers. So 8 times 2 gives us x to the 16th. Y to the negative 3 raised to the power of negative 4. Negative 3 times negative 4 gives us positive 12. So it's y to the 12th. Okay, pretty simple there. Now, moving on, if we have the power of a product, what happens is that this exponent goes in and it multiplies everywhere. So it goes to each power. But what we need to be careful about is that we multiply, I want to add on here that we multiply to each exponent. That's very important that we're multiplying to the exponents. A lot of students will get this first problem wrong because what they do is they say, okay, we're going to multiply the 3 to all of these, but when they get to the 4, they do 3 times 4 and they get 12. It is not 12. And the reason it's not 12 is that we're multiplying it to all of the exponents. Well, what I want to kind of add in here is what are the exponents? The exponent to y, it doesn't have one, so it's y to the first power. Z doesn't have an exponent, it's z to the first power. And same thing with 4. 4 doesn't have an exponent, so it's 4 to the first power. So anytime we have a number, we want to be careful about that it's to the first power. So this 3 is actually multiplying to all of those exponent numbers. So it's 4 to the 1 times 3 gives us third power. X, 3 times 3 gives us to the 9th power. Y to the third power, and z to the third power. You can just write it like that. You could simplify the 4. 4 times 4 is 16, times another 4 is 64. So, if you really wanted to be fancy, you could write it like that. But for us, for delta math, what I boxed is okay. All right. Now, the next one, same thing. So I'm going to put in 7 to the first power, x to the first power. Then I'm going to multiply this -2 to each term. So you get 7 to the negative second, x to the negative second, y to the positive 4, because negative times a negative gives us a positive. Now, in math, what happens is we never want to have negative exponents in our answer. It's just kind of a math rule that we never have negative exponents. So now we're going to have to go back and use that last rule about those negatives. So if we don't have a fraction, we can just lollipop it, divided by 1. Anything is, you can always put divided by 1. It's going to stay the same. So now I'm just going to kind of circle the two that, we want to move. The ones with the negative exponents are going to move. And then y to the fourth is going to stay because it had a positive. So on the top in the numerator, we're going to have y to the fourth divided by 7 squared x squared. And if you want to change 7 squared to 49, you can, but I'm going to leave it like that. Okay, next one, very similar. Again, 6 needs to be to the first power. So I'm going to multiply this -2 to each exponent. That gives us 6 to the -2, x to the positive 12, y to the positive 14, and 0 times 2 is still 0. So z to the 0 part, that part just goes to 1. Anytime you have 1, it just goes to 1. And now I'm going to move the one that has a negative down, because like we said, we don't ever want to have a negative exponent in our answers. So we get x to the 12th, y to the 14th, divided by 6 squared. Right? And on delta math, they will get this hard tomorrow, but for today, they're going to be a lot easier. Okay, and then our final rule is the power of a quotient. And this rule is actually very similar to the rule 5. It basically says if we have a quotient, we just multiply that power to the numerator and to the denominator. So it's very, very similar to the other rule. So in this case, right, and again, it's not 6 divided by 10. A lot of people do 6 divided by 10 here. That's wrong. Remember, we're multiplying by the exponents. So I need to put a little 1 there and a little 1 there. So this is 3 squared divided by 5 squared. That would be the right answer. If you want to, you can do 3 squared. 3 times 3 is 9. 5 times 5 is 25. That would be the same answer, but either way is okay. All right, same thing here. It's we need to put in the first power. So 2 to the 1 times 2 is 2 squared. A to the 10th divided by b to the 14th. And I'm just going to leave that as my answer. Okay, again, this one's going to be a little trickier because of the negative. So 3, remember there was a 1 there. So 1 times 3 is 3 cubed. A to the -12th over b to the 7th. And now I don't ever want to have any negative exponents. So whenever I have a negative exponent, I just switch sides. If it was in the denominator, it would move up. If it's in the numerator, it moves down. So we get 3 to the 3rd power divided by b to the 7th times a to the 12th. If you want to put the a in front, it would be the same answer. You could have a to the 12th first and b to the 7th second. It doesn't matter the order. Right? And then finally, with this -6, because when we multiply a negative by a negative, it turns positive. All of these are actually going to be positive, and we don't have anything that we need to worry about. All right? So that's kind of putting these all together. Now, when we do move on to delta math, so on delta math, today it's going to be a little bit easier. You are going to have to use all 6 of these rules, but it's going to be with just numbers. So you're going to get things like, maybe 2 cubed times 2 to the -3rd. And, okay, that's rule 1 where we add. So 3 minus 3 or 3 plus -3 is 2 to the 0th. But now that's that next rule, that third rule, which anything to the 0th power is just 1. So that's an example of a little bit of a harder one. But then we'll also have some pretty easy ones, like just say 2x squared cubed. And just remember to put the 1 in, and 2 cubed x to the 6th power. So today's is going to be a little bit easier, and then tomorrow we'll take it a step further. If you guys have any questions, make sure you email me, or if you're not in my class, make sure you email your Math 1 teacher. And good luck on the homework, and I hope this helped.